In this video, we're going to be looking at how the ideas of equilibrium that we've been talking about relate back to precipitation reactions that we talked about in our first unit. So we've been talking in the last couple videos about solubility equilibria, which have an ionic solid in equilibrium with aqueous ions, meaning that the forward reaction is dissolving and the reverse reaction is precipitation. So we've been talking about these ideas of solubility and how they relate to equilibrium, but I specifically want to look at how this can let us determine whether a precipitate will form or not. So in this first example, we're still dealing with the same lead chloride equilibrium. We are asked if 0.01 moles of lead and 0.01 moles of chloride are combined in a liter of water, will a precipitate form? So will a precipitate form is really asking you, will the reaction run in reverse? Whenever we are talking about a solubility equilibrium, the forward reaction is dissolving, the reverse reaction is precipitation. So asking you, will the precipitate form, is really just asking, does this reaction want to go backwards from where it is right now? So if these are our current concentrations, we can figure that out using the tools that we have available to us already from our discussions of equilibrium. So I would like you to take a couple minutes and try and figure out how to approach this problem. What do we usually use to figure out which direction a reaction wants to go? So to answer this question, will a reaction want to go forward, reverse, or nowhere, is when we compare Q and K. So our reaction will want to run in reverse when Q is greater than K. So that means we need to calculate Q in order to solve this problem. So Q is calculated using the equilibrium expression, which we wrote in previous videos was lead concentration times chloride concentration squared. And we can plug in the values we were given for concentrations from the problem. So if we do this out, we get a value for Q of 1 times 10 to the negative 6th. K is 1.6 times 10 to the negative 5th. So for this reaction, Q is actually less than K. So what that means is that we have less than the maximum concentration of lead and chloride in this solution, that we could add more product, we could dissolve more lead chloride before we reached equilibrium. So this is an unsaturated solution. It is not going to form a precipitate. So when we first introduced the idea of solubility, and that some things are soluble and some things aren't, I mentioned that even things we say are not soluble in water do dissolve to a very small extent. So 0.01 moles isn't a lot, but it's not nothing. It's not like a super tiny amount of stuff. And that is able to stay dissolved. So even though lead chloride, if you look at your solubility rules, is considered insoluble, this is a case where we wouldn't see a precipitate because we could have more dissolved ions. These concentrations these ion concentrations are less than the maximum, or less than the molar solubility, we could dissolve more lead chloride. So this reaction would want to run in the forward direction to reach equilibrium. If solid lead chloride was available, it would react to produce more product, that more of that would dissolve. So we would not see a precipitate in this case because our Q value is less than K. We only see a precipitate when Q is larger, meaning that our reaction wants to run in reverse.